So in the previous video, we understood the Bronsted-Lowry concept, and we understood that it does not depend on the nature of the solvent, like whether the solvent is giving H plus or giving OH minus ions inside it. Instead, we understood it as a concept of proton transfer, right? Now, similarly, we understand a new concept in this case, which was proposed by Lewis. So it was not a new concept in the sense that it is recent, but it was proposed after the Bronsted-Lowry concept. So a development. So what is this concept? It says that acid is any substance atom, molecule, or ion that can accept an electron pair from any other atom, molecule, or ion. So we are now talking about electron pair acceptance or donation. Okay. So acid is any atom, molecule, or ion that can accept an electron pair from any other atom, molecule, or ion. Okay. Similarly, base is any atom, molecule, or ion that can donate an electron pair, not from, here I will write it as, to any other atom, molecular ion. So one which accepts an electron pair is an acid, one which donates an electron pair is a base. So let's see some examples. So let us say NH3, we know it's a base, but let's see its reaction with H plus will give NH4 plus. Okay. Now NH3, if you see nitrogen has 5 electrons in the valence shell, right? So 1, 2, 3, 4, 5. And when it combines with hydrogen to form NH3, what's happening? There are 3 bonds formed. So first electron of nitrogen is combined with electron of hydrogen. Second electron is combining second hydrogen atom. And third electron is combining with third hydrogen atom. Sorry, H. So basically we have 2 more electrons left, which is called lone pair of electrons. So we are focusing on this lone pair of electrons. Okay, so whenever we have NH3, we will write NH3 as having one lone pair of electrons to understand the Lewis concept better. So what is NH3 doing? It is donating this electron pair to hydrogen. It is donating this electron pair to hydrogen and forming NH4 plus. So how it is forming NH4 plus is N. We already have one hydrogen, other hydrogen, third hydrogen bonded, as we saw here, the right side. So this fourth hydrogen, now this hydrogen is hydrogen plus, so doesn't have any electron. For a bond formation, it requires 2 electrons. So these 2 electrons are given by nitrogen in this case. In the previous case, this was 1 electron of nitrogen, 1 electron of hydrogen, 1 electron of nitrogen, 1 electron of hydrogen, 1 electron of nitrogen, 1 of hydrogen. So NH3 was about sharing of electrons. But for NH3 to form NH4 plus, both the electrons which are shared between nitrogen and the fourth hydrogen atom, they are given by nitrogen from its lone pair electrons. So that is how we understand. So because NH3 is donating this lone pair of electrons to form the bond with H plus, we have NH3 as base. Okay. Similarly, in this case, H plus can be considered an acid because it is accepting the electron. Let's see one more example. Before we go to the second example, let's understand that NH4 plus is called as an adduct. We can write NH4 plus as this, we can write as NH3, and there is a coordinate. We can write this NH4 plus as this to indicate. So this is an adduct. Similarly, when we take up the second example, let's say boron trifluoride plus NH3. Now here, if you understand boron has 3 electrons in the valence shell. So each of these 3 electrons are shared with the electron of fluorine atoms. So we have BF3. Now Boron has not completed its octet, so it is deficient in electrons. It needs one electron pair, right? So that is donated by nitrogen, because we know that nitrogen in the ammonia, because in ammonia we just now saw that nitrogen has one lone electron. So now this will form an adduct. How will you write an adduct? Boron trifluoride, and both electron pairs are donated by ammonia. So this is an adduct compound we are getting. And here again, because nitrogen has two lone pair electrons from ammonia and boron needs those electrons, we can write this is given by nitrogen, and nitrogen has already bonded with hydrogen using its three electrons, and the fourth lone pair of electrons it is donating to boron and forming this adduct. So in this case, because boron trifluoride is accepting the electrons, so it becomes an acid. Ammonia is donating electrons, so it becomes a base. This is called Lewis acid, and this is called Lewis base. Similarly, in case of ammonia converting to ammonium ion, this is ammonia is Lewis base, H plus is Lewis acid. Okay, this is the concept of Lewis for understanding acids and bases. Similarly, instead of boron trifluoride, we can also see aluminum chloride, which is again a Lewis acid, because if you see aluminium also has three electrons in the valence shell, and it is sharing with chlorine. Now, in this case, aluminum being a metal, but this is more about sharing when it forms aluminum chloride. Okay, so and aluminum is again deficient in two electrons because it requires an octet to form stable configuration. So same like boron trifluoride, aluminum trichloride also can accept an electron pair from ammonia and form an adduct. In this case, it will be AlCl3, and that lone pair of electrons for sharing is donated. So normally in covalent bond, what happens is one electron is taken from one element and other is taken from other element and they share. But here, for sharing purpose, both the electrons are donated by one of the species only, and that is because it has a lone pair of electrons. So that is how we get this adduct, and an electron pair deficient substance reacts with an electron substance having a lone pair of electrons, an extra pair of electrons, to form this. This is a covalent coordinate covalent bond we call it. So it's an adduct. So therefore, in this case again, AlCl3 is a Lewis acid because it takes electrons pair electron pair, and ammonia is a Lewis base because it donates the electron pair for sharing. Okay, so this is the Lewis concept of acids and bases.